Welcome friends to my channel. Now in today's lecture I shall going to discuss the an important topic, that is lecture number 3 of magnetostatics, that is force on a current element. Force acting on a current element placed in a uniform magnetic field. Okay, now you all know that the conventionally the direction of current is along the direction of positive charge. You all know it. Okay, so we assume that n represents the number of carriers per unit volume. Okay, and q is the charge of each carrier. Okay, and suppose dl be the small current element that is placed in a uniform magnetic field. dl be the small current element. Okay, fine, and we assume that all the carriers are moving with uniform velocity, that is say v, velocity of carriers. Velocity of carriers. For simplicity we assume that all the carriers move with uniform velocity. Okay, these things we imagine. Okay, fine. Now if we assume that the current is due to the drift of positive charge carriers only, that I told previously that the direction of current is the direction of the flow of the positive charge carriers. Okay, the direction in which the positive charge carriers flow, that is the direction of current. So assuming the current is due to the drift of positive charge carriers, what we can write? Charge by time. Okay, so if n is the number of carriers per unit volume, so what would be the volume? A dot dl. If A is the cross sectional area of the element. Okay, if A represents the cross sectional area of the element, then this is the volume and this is the number of carriers per unit volume. So this is the total volume. Okay, and this is the total number of carriers within this volume. Okay, this is the number of carriers per unit volume, and if we multiply it by q, so this represents the total charge. Okay, by infinitesimal time t dt, or you can write nq a dot v, or you can write this expression in one line, nq a dot v. Okay, so this represents the current. Now you all know that magnetic force acting on each charge carrier is q into v cross v. Okay, so magnetic force acting on each carrier is what? q into v cross v. Okay, so what would be the total number of carriers in the current element? Okay, so number of carriers in this case per unit volume is n, and this is the total volume. Okay, so these are the total number of carriers. Okay, so force on each carrier is this and the total number of carrier is this. So if we multiply these two, we will get the force acting on a current element. Okay, force acting on the small current element. Okay, so we have to multiply it. force acting on the current element. If we call it dF, simply multiply A dot dl V cross B. Okay, so we can interchange it. V means dl dt, and that dt we can put here, that is dl dt means V, so we can interchange this. Okay, and this is the current I, so I into dl cross B. Or if we take the magnitude, so df is bi dl sin theta. Fine. So this is the force acting on a current element placed in a uniform field. Okay, now let us simply discuss the few cases. Okay, let us simply discuss the few important cases. Suppose what happens for a conductor of length L. So for a conductor of, say, length L, what happens? F is simply BIL sin theta, that you all know. Okay, now what happened? For a closed loop, the force will be 0. For a closed loop, what happens? Bi sin theta, this is dl, and for a closed loop this integral is 0. Okay, so these are the special cases. Okay, so in today's short lecture I discuss about the force acting on a current element which is placed in a external magnetic field. So dear guys, if you like this video, then kindly share to your friends. Okay, and subscribe my channel to get latest videos. Okay, thank you.